Oh. Okay. I was doing that? Yeah, you did a beautiful job. Okay. Just to make sure we're using the right problem. I've done that a gazillion times, though. Like.
Wait, I have a question.
Yes, dear.
Do we divide?
Yes.
Okay.
Yep. All right.
I'm gonna wait to see.
So on this first one, what is our first step? We got to make it so it's not in our absolute value brackets anymore. How do we do that? Remember, this is when we had our 4 steps where we would isolate. Already is isolated, so we don't got to do anything. Split. Solve. And check. So it's already isolated, so we don't have to do anything. So we need to split it into our 2 cases. So maybe for this chunk, my absolute value bars aren't doing anything. Maybe my 2x plus 6 really does equal 12, and those absolute value bars are just decorative and in the way. Or maybe my 2x plus 6 actually equals negative 12, and those absolute value bars are working, and that's what makes it say positive 12. Because absolute values are always positive. So we have to split it into our 2 possible cases. So it came isolated, and then we split it into our 2 possible cases. This 2 cases is important. You have to have both. So then I need to solve each of these. On my blue one, what do we need to do? Add 6. So we're going to add 6 to both sides to have, oh, yeah, you're right. What do we got to do? Subtract it. I was going to say, I will rock with the wrong answer sometimes just to make sure we're catching it. 100% call me out when something like that happens. Because sometimes it's that I'm totally following the wrong answer. Sometimes I'm totally hearing things absolutely correctly. My ADD is ADD and hard today, guys. 100%. I don't know why, but it is just. All right, so 12 minus 6 gives us 6. That one I did do right. Yeah. Now what do? Divide by 2 on both sides. I need to get x by itself when we solve. So we're going to have our x equals 3. Same vibe on the purple one on the right-hand side. What do we need to do? Subtract 6. Properly subtracting this time. Woohoo. So we're going to have our 2x equals negative 18. Then we divide by 2 again to get our x equals negative 9. So we've done our solving. For our check, we can take these pieces, substitute them into here, and see if that will make an absolute value of 12. And you can use our calculator for that. My 2x plus 6, when we do that in the calculator, hello calculator, come back, thank y'all. So 2 times 3 plus 6, we do get a positive 12. The absolute value of positive 12 is 12, so this one checks. When we do our negative 9, 2 times negative 9, when we're doing negatives in the calculator, it's super duper important to use this negative sign. Do not use the minus. The calculator sees those as 2 different things. Even though they look the same, the calculator sees them different. This is negatives. So 2 times negative 9 plus 6, hello calculator, plus 6. We get negative 12. The absolute value of negative 12 is positive 12. So this one also checks. Questions on the first one? For our checks, that's all we really have to write down. We just put a check mark next to it. That totally works. So same vibe on the right-hand one. Wait, hang on, before I do that. Questions on the first one? Okay. Same vibe on the right-hand one. What's my first step going to be? We can absolutely do that. If you want to divide by 2 first, that is 100% valid. And on this one, I'm not going to talk you out of it because all of our other numbers are even. If I divide everybody by 2 like this, that's totally fine. Sometimes if we start with our dividing step, it's going to give us fractions, which is, but in this case, it's going to work just fine. So this is one of those times when you have choices on what order we do things in, and neither one is going to make it harder than the other. So sometimes if we divide first, it will make things more difficult, but in this case, it's totally fine because this 2 and this 2 cancels out, and we're left with our absolute value of x plus 5 minus 2 equals 7. 100% valid move. You could absolutely start off by adding 4 and then dividing by 2. You will get the exact same answer. Use plus 4 on both sides, and then on your next step, you divide by 2. Because here we divided by 2 first, and now my next step is going to be that we need to add 2. So I'm still moving this chunk to the other side. Either way, we're going to wind up with our absolute value of x plus 5 equal to 9. No matter which order we do things, if we subtract first, or if we add the 4 first, or if we divide by 2 first, we should wind up at absolute value of x plus 5 equals 9. So that's one of those times when I was talking about we have choices in how we do it. There's no one exactly right path through it. There's multiple paths. So now that we've got our absolute value isolated, we're ready. So isolated, we are ready to do our split, where I take this chunk and say, well, maybe my absolute value bars aren't doing anything, and x plus 5 really does equal a positive 9. Or maybe my absolute value bars are working, because maybe x plus 5 actually equals negative 9, and the absolute value is making it be positive. Because absolute values always make a positive number. So we're always going to take our what's inside the absolute value and set it to the answer over here that is positive, or the negative version of this number. So we have to split it. Now let's solve each one of these. What do we got to do? Subtract 5 from both sides. So my purple one's going to be that x equals 4. On the blue one, we subtract 5 from both sides. And we're going to get that x equals negative 14. When we are checking, I do recommend that we go back to our original equation. If we are super confident in our solving abilities, you can use it when it's isolated. But that requires us to have made absolutely 0 mistakes in this part. Okay? So I recommend going back to the beginning, and we're just going to do it in chunks. We're going to look at our inside the absolute value and then substitute that value in. I'll show you what I mean. So on my, it's like I know I wrote it down, but I gotta have it. Boop, boop. All right, so on my 2 times x plus 5 minus 4, and we're going to start with our x equals positive 4. In my calculator, I'm going to do my absolute value part first. My 4 plus 5, that's a positive 9. So inside the absolute value, I have a positive 9. So then we can do 2 times 9 minus 4. Whoop, this is me substituting them back into the original up here. I'm taking my x of 4 and substituting it in up here. But since our calculator doesn't have an absolute value button, I have to do this piece by itself first. So this is my first step. And then I'm going to substitute that into the whole thing. That's my second step. So back to my calculator. So my first step was that my absolute value inside of it was a positive 9. So my absolute value bars aren't actually doing anything. So we have 2 times our absolute value of 9, which is just positive 9, minus 4. That equals 14, and that is exactly what we wanted it to equal over here. So this one checks. I'm going to do the same thing with the negative 14 and show you how to deal with if this chunk is negative. So when we substitute that in, I'm going to look at my absolute value first. My negative 14 plus 5 is negative 9. So what's inside my absolute value is a negative 9. So if we take the absolute value of negative 9, that's positive 9. So when we're substituting it into our equation, I'm going to put in a positive 9. So we're going to have 2 times 9 minus 4. So that one also equals 14, which is exactly what we wanted it to equal. So this one also checks. When it's inside the absolute value, so inside the absolute value, it's only going to be positive. So it's going to be 2 times a positive 9 because it's the absolute value of negative 9. That's why we have to do that x plus 5 first, so that we can make sure we take the absolute value of that number. Because these calculators don't have an absolute value button where we can type that in. If it did, it'd be a whole lot easier. So but then we take the absolute value of that, because that's inside our absolute value bars. So how many steps is negative 9 from 0? Because we're substituting in, right? Either negative 14 plus 5 is this chunk. And we got negative 9. When we take the absolute value of it, that means positive. So the absolute value is always show us the positive every time. Okay, so then it's 2 times that positive 9. Always. Always. In fact, that's what we're going to really focus on today. Okay? Because that's where we can see wrenches sometimes. So questions on these two. We are going to practice more with absolute values. They're not going to get worse. We're just going to see what happens when we see some weird things sometimes. Because I know sometimes I like kick it up a notch, and then up a notch, and then up a notch. We get into some real crazy stuff. They don't get worse than we did yesterday. We're just going to see more of them. Okay? So we're going to start with this one. And this one's going to show us one of the times that they like to throw wrenches at us. So we need to do our distribution first. We have to distribute and distribute our minus sign, but then yes, absolutely. So we have, well, oh, hang on a second. We can't distribute the 4. Whoa, how is that? Oh, you're on homework 1. Sorry, I was looking at homework 2 1. That's homework 1. Yes, absolutely. Distribute our minus 4, distribute our minus sign, and then divide our like. That's exactly what we're going to do there. Yep, and we're going to distribute that minus 1 to both of you. Yes, gorge, just like that. Yep. Okay, so let's look at this one. This is one way that we love to throw a kind of tricksy one at you. It does not look tricksy, but it is.
We would distribute our minus sign too?
We would need to do that for that particular question, yes. So, we're going to go back up to this one though. No worries. I'm just trying to not do the tangent thing too many times. What are we going to do as our first step on this one? Subtract 10. Thus far, nothing different than normal. So, hang on. I'm going to block this out. So I'm going to subtract 10 from both sides. That's going to give me my absolute value of 4x minus 7 equals negative 8. What next? Let's see if we can split it. So we want to know if this guy, if my absolute value bars aren't doing much, 4x minus 7. Absolute value bars always give us a positive answer. So wait a second. Is there any way that I can have a number inside here, inside an absolute value that's going to equal negative 8? Because absolute values, Apple Watch, remember? There are how many steps? Is there any way I can take negative 8 steps? No matter how hard I try. Can I undo 8 steps? I'm trying really hard. So my absolute value, can it equal a negative number? No. So if we have an absolute value in isolation, so it's already isolated, my absolute value equals a negative number. No x's, no nothing else. Can't do it. It's not going to work. If you got all the way to the end, like if you set it up and forgot that and then went back to check, it should still wind up as not working. But we can notice right here, absolute values cannot equal negatives. They cannot equal negatives. So is there any x in the entire existence of the universe that will make that work? No. So what's our solution here? No solution. We could absolutely have no solution. There is a shortcut to write no solution that I'm going to show you because, I mean, yeah, it's only like, what, 10 letters? But sometimes that's a lot of writing. We don't like to write words, and it's not just NS. Oh, yeah, let me write your past a second. I'm going to write this out, though. So we could say that my x cannot equal anything. We take a 0 and we cross it out big.
Oh.
That means no solution. That is also called the empty set. It is not 0. It is not 0. I can take no steps. Ta-da, I just took no steps. 0's a thing. Ta-da, I just did it again. No steps. 0's a thing. I can take no steps. What I cannot do is take negative steps. I cannot unstep a step. So 0 is an answer. However, it's not this answer. Okay? So do not tell me that x equals 0 means no solution. X equals 0 is a thing. I can take no steps. It's like, ta-da, no steps. I just did it again. No steps. I can have 0. This means there's not a solution. You can also write no solution. I just wanted you guys to see what this looks like. Crossed out 0 means no solution. It's called the empty set.
If it equals 0?
Nope. If it cannot happen. Equals 0 is the thing. That just means no steps. I did 0. No steps. 0 is the thing. We can have 0. I cannot have an absolute value that equals a negative number.
Wait, so if it automatically equals a negative number, we know that it's no solution.
Mm-hmm.
No matter what it is.
No matter what. If it's a negative number.
And we just put the 0 on the side.
Yes.
Okay.
Or you can write no solution. I don't care which one, but I wanted you to see it because especially people like the PSAT board would have that in your list of multiple choice options and we'll go, guess it's a weird 0? So I wanted us to see it before we got to PSAT next month. So that just means no solution. But mathematicians try and do as many things without words in our answers because math goes across all kinds of languages. And so if we have that symbol that means no solution, we don't have to translate that into a gazillion different languages. So that's why we have some of these weird symbols, is so that no matter if the person who writes the research papers speaks in English or in German or in Cantonese, we can read their math work. It's all the same symbols. So that's why sometimes mathematicians have some weird symbols that mean things that we have easy words for. Okay? It's not a super duper common thing, but it is something that we will see. So questions on this one? Okay. Let's do another one. Trying to pick which one we're doing. This one. No, I want to do this one next. We're going to do this one next. So I've got the absolute value of x plus 10 equals 4x minus 8. So, what's my first step going to be? Do we need to do anything to isolate it? My absolute value is already by itself, so we do not have to do any steps to isolate it. So my isolate step is done. I'm just going to not write out all the words. I'm just going to put version initials. So isolate, it already is. So we're ready to hop straight into splitting. So we want to set this chunk equal to the right side or to the opposite of the right side, just like we did in the bell work. Just because there's an expression over there doesn't change what we do. So these are kind of the hard ones that we did yesterday. So it could be that my x plus 10 exactly equals what the right-hand side says. Since there's an x over there, we got to be careful and make sure that we include that. If there's an x outside my absolute value, that negative thing does not come into play. We'll have to solve it all the way and check it. So my x plus 10 could exactly equal 4x minus 8. That's absolutely one of the options. Or my x plus 10 could equal the opposite of the right side. Just like in the bell work, we had our positive 12, negative 12, positive 4x plus 8, or negative 4x minus 8. Sorry, minus 8 on the first one. So just like we did with our numbers, positive on one side, negative on the other. So then we're going to solve each of these. That's my split. So we did that step. Now we're ready to solve these. So we're going to look at the blue one, my left-hand one. What do we need to do to solve this? Over here. Lots of pathways through it. Say it louder. Add 8. We can absolutely add 8 to both sides. Get those numbers on one side. Plus 8. That's going to give me x plus 18 equals 4x. 100% valid. What else do we need to do? Which, more specific? The blue step? So this is when we've already got our absolute value isolated. So I take my what's inside and set it equal to the right side. So we're splitting it into our two options. So this chunk stays the same here and here. And it could be this guy, or it could be the opposite of this guy. So our two possible options, just like when we had 12 or negative 12 in the bell work, it's 4x minus 8 or negative 4x minus 8. So we're just splitting into our two options. Yes. Because we always want the positive version and the opposite of the whole side. So what do we do as our next step here? Subtract x. Because I want to get my x's together too. So I'm going to minus x on this side and minus x on this side. So that's going to give us that 18 equals 3x. One more step. Divide by 3 to both sides. Whatever we do to one side, we do to the other. So my 3's cancel out over here. We're left with our just x equals 6. They can be fractions. Yeah. They're not pleasant and they're not super common, so if we're getting fractions every single time, double check with me. But it can be fractions, and I'll show you how to deal with that for our check. All right, let's look at the right-hand one. I always set it up with my parentheses like this with my minus sign. If you are able to do that in your head and kind of distribute that minus sign through, I am 100% okay with that. But I just like to write it out for people that don't do that in their head, and that's okay. So our first step on the right-hand one, we need to distribute this minus sign through. That's got to be our first step. That has to be our first step. So we're going to have our x plus 10 equals negative 4x plus 8. We have to do that distribution first. That has to be our first step. Otherwise, we're making our life way harder. Now I have lots of options for where to go. What is your instinct on what to do next? What should we do next here? There are about 4 options that I can see off the top of my head that I could see somebody thinking. Add the 4x. If you always move your smaller x, you will have fewer negative numbers to deal with. So on this last one, we moved the single x because 1x is smaller than 4x, and we want to put the positive value. In this case, negative 4x is smaller than x. Oh, she's in such a mood today. There. So if I move the negative 4x, that is in fact smaller than my x. So it's going to give us less negative numbers. That's not a thing you have to do. It's just negative numbers sometimes make us go. So it's a way to make it so you don't have as many negatives. So this is going to give us 5x plus 10 equals 8. Then what? Subtract 10. I need to get those numbers to the other side. So that's minus 10. Minus 10. So we're going to have our 5x equals negative 2. One more step here. Divide by 5. I need that x by itself, so we're going to divide both sides by 5. So my x equals, and you can either do this as the fraction, negative 2/5, or you can put this in the calculator and get it as a decimal. Negative 0.4 is what this will be. Genuinely, it does not matter to me. Whichever one of those makes you go, less. It does not matter at all. They mean the same thing. They are equivalent. So if you are comfortable with fractions, rock on. If you are not comfortable with fractions, switch it to a decimal. 100% totally okay. So then we need to do our checks. So when we do this, we're going to go back to our original absolute values. And we're going to type some things in. So I'm going to, and I'll come back and I'll write them on this page as well, just so that we can see it. So our first one with our 6, inside our absolute value, we had x plus 10. So we're going to have our 6 plus 10. That's a positive 16. So when we check our 6, we wind up with the absolute value of positive 16 equals 4 times x minus 8. So we'll do 4 times 6 minus 8, substituting our 6 backs in, and we get 16 again. So absolute value of 16 equals 16. That does check. When we do the right-hand side on our check, you, again, can do this as negative 2/5, or you can do it as negative 0.4. Either way is fine. Our calculator has my most favoritist button in the whole wide world. Second column, third button down. Fractions that look like fractions. We have our -2 on the top, divided by 5. Hit our right button, and that gets us out of our fraction. Plus 10. And we get, 48/5. That's ucky. So let's switch it to a decimal. There is a button on here that'll do that. Right above the enter key are those 2 arrows. That switches it to a decimal. We get 9.6. So our left side here is the absolute value of 9.6. My right-hand side, when we do that, I'm going to do it the same way. We're going to have our 4 times our fraction of -2 over 5 minus 8. And we get -48/5 or -9.6. -9.6. Does the absolute value of 9.6 equal -9.6? Those are not the same things. My absolute values do not give us negative numbers. So this is not a valid answer. This does not check. Oh my gosh, they make us do so much work and it's not even a real answer. Oh my gosh, that's so extra. Oh my god. Oh my god, it's so extra. I will continue to say it like that all year long. Because when they make us do all that work and oh my god, it's so extra, it is called extraneous. If you write so extra, I will 100% take it. Because I do that to help us remember it. Because, oh my gosh, they made us do so much work. It is so extra. Oh my god. No, you do not have to write that down. I was just doing that because when I switch back and forth to the calculator and back to the screen, it's sometimes really hard to track what I'm saying. So I'm just trying to help with that visual tracking when I'm tab switching a gazillion times. Because not everyone has a gazillion tabs open in their brain all the time, and that can also get the tab switching because ADD is fun. And my ADD is ADDing hard today. So it is extraneous. If you just do the check and the X, I will also take that for here. We're going to have times later in the year where we do need to make sure we can write extra or extraneous because it will come up throughout the rest of the year. But again, I will take extra, 100%. Totally fine. It means the same thing and you know the concept. I do not care about spelling because spelling is a construct and grammar is a suggestion. Close enough for Google, it's close enough for me. Because y'all already know my spelling is atrocious. Okay? So that is why it's important to check. Sometimes we get answers that don't actually count. So this one only has one solution where x equals 6. But it's important that we have both pieces and that we check them. That's why we have the check as a step and why we've done so much checking, even though a lot of the times it didn't make any difference. Because it does make a difference. Okay? All right. I know we had a lot of people with questions on homework 1, so I'm actually going to stop us here so that we have time to ask questions and look at things. I'm also going to pass out homework 2 so that we can look at that because homework 2 is due on Monday. You also need to turn in your bell work for week 8 and your homework 1 is due today. Okay? So I'm going to pass out homework 2. If you picked it up yesterday, let me know because there's a typo on it and I can fix it real fast. Okay, I can fix it. I will. So if you grad out your homework 2, I will fix it for you. Super duper fast. It's just there's like one little piece on the picture on the back that didn't print out for some reason. So because the error evaluation on the back is all about the check. So, okay, I got one there. Okay. Awesome. Good. Hit me with it. Mm-hmm. grab it out and put it on the back, and I can fix it super duper fast. Because there's just a teeny tiny little typo. It's X. We're supposed to have pictures on it, and it's not. Otherwise, it's like nothing to do that. What happened wrong? And you also have 2.2 you need to fix them?
Can you help us with this question?
Yes. Off your pants. I was like, you can use the Clorox wipes, but I don't know that I recommend it for fabric. I have. These are like hand sanitizer wipes. It's more like a rubbing alcohol, so it shouldn't stain your pants unless the Clorox wipes have bleach in them. So if you use them in your pants, it can change the color. But those ones shouldn't do that. They're just rubbing alcohol. It says it doesn't have bleach, but it doesn't this color, so. I know sometimes I'll take that there. These down, and then today I do.
Yes, what is that?
So, solve for P means they give you P equals. So, you got a whiteboard. So, we got L equals PRT. So if it was, I want this guy. So what if this was X and this was, I don't know, maybe 2 times 3 equals, what would we do to get this X by itself? What's happening between my X and 2 and my 3? If they're smashed together? Multiply. So how do I get rid of the 2 and 3? Right? So even though it's not a 2 and a 3, it's an R and a T.
That's permanent. I was sure what she was doing. I'm like, what is she doing?
Trust me, I can fix a lot of things. So we know that these guys are multiplied together, right? So how do we undo multiplication? Division. So you're going to divide by what we did. The R and the T. You're going to divide this side by the R and the T. That's going to make these two guys cancel out. So on this right hand side we have the T. And over here we have a hot mess. And that's okay. We have L over our R T. So on this one we find the T and T. So just imagine all those irregular numbers and see what would we do? We're going to divide by, well, we want to keep the H. And 2 is divided. So we can absolutely start there. I'm saying this guy be a little funky, but you can absolutely do it. We can get this guy and A.
She think about it.
Because he's not H.
We don't want him.
Yep. Plus, what's left here? We have 2 plus, which means what's left? The 2. So R squared means this is 2 pi R, right? So one of the R's is up, which would be an R. All but one of the R's. All but this by the A by. Oh, okay. So like that, we're going to get an H equals. What do we do with that?
Wait, the A also goes by that.
Okay, everybody gets one of that. A over our 2 pi R. So down here we have the A over R. Yep. I still need my H by itself. What do I need to do?
So we're subtracting off. We're subtracting and canceling out. We're just subtracting off. Minus R. Yeah. Wait, so she said, can we just bring this back? Because I can't. Yeah. All right.
Literally, that was the only permanent one in here. I'm looking at the rest. The rest of these all say dry erase. But that one like so matched my dry erase set.
Yeah.
But there's literally none else in here that say it, so I didn't order a wrong box.
I probably put it in on mistake.
I was gonna say, somebody must have found it and thought it was mine. All right.